The objective of this tutorial is to highlight and discuss the top 5 tips that can help you achieve the best or the optimum performance from your flame atomic absorption instrumentation. We'll highlight the potential issues that can impact performance and provide some tips and maintenance recommendations that can help you avoid common problems that can occur with sample introduction, standard and sample preparation, and even with optimization of your instrumentation. So these tips and guidelines should help you achieve the optimum performance from your flame atomic absorption instrumentation. So now let's think about some of the other tips and tricks that we can provide to help you maximize the performance of your atomic absorption system. And I guess we're really going to focus on the other 4 tips that are important to maximizing performance. So we'll look at what's important about preventing nebulizer blockage, about doing maintenance of your sample introduction system, about checking the analytical sensitivity that you're achieving, and of course about what you need to do to make sure that you're getting accurate standards and accurate results from your analyses. So let's think about some of the things that we can do to help prevent nebulizer blockage that might occur with your flame atomic absorption system. Now, of course, there's a number of things that we can do. And one of the most important of those is to work with a rinse solution, a reagent blank solution, to rinse the nebulizer between samples, but especially to rinse for a few minutes at the end of the run before we extinguish the flame. That allows us to wash out any remaining sample residue from the nebulizer and can help to prevent blockage occurring. Now, sample preparation also plays a critical role here. What we really want to do is make sure that we're removing any large particles from the sample that may be contributing to cause nebulizer blockage prior to the analysis. So that means we need to either filter samples, centrifuge samples, or allow them to settle gravitationally so that those larger particles will not be drawn through the nebulizer. For the same reason, if we're working with an autosampler, or even if we're just working with manual sampling, we want to make sure that we're sampling above the level where there's any sediment in the sample vessel that we're working with. And we also need to make sure that if we're wiping our sample capillary between samples, that we're using lintless wipes. Otherwise, the fibers can build up, can be drawn through the nebulizer, and potentially can be a cause of nebulizer blockage. Now, of course, once we have a blocked nebulizer, then really the best way to solve that is to disassemble the nebulizer completely and sonicate the components in a detergent solution in an ultrasonic bath, as we're showing here in the photograph. You can then rinse and reassemble the nebulizer. It is also possible to work with a cleaning wire to clean the nebulizer, but really that's just a short-term solution. So if you actually get a blockage, it's best really to disassemble and clean the nebulizer. But as we said earlier, the most critical thing is really to think about prevention. And taking some care with sample preparation and rinsing your sample introduction system can give you great benefits in helping you to prevent nebulizer blockage occurring in the first place. We should also think about some things that we need to do to help us tune the atomization system, because that can also help us to reduce nebulizer blockage. So in terms of the settings that we work with in flame atomic absorption, for most flame atomic absorption applications, we want the mixing paddles to be fitted inside the spray chamber, as you see here in the schematic diagram. We then optimize our impact bead position so that we're getting that best combination of sensitivity and precision. And we work with the standard narrow bore capillary tubing. That works well with most applications. What if you want more sensitivity? In those cases, then really what we'd say is you should remove the mixing paddles from the spray chamber. That will enable you to get more sensitivity. You should also fit wider bore capillary tubing, which means you'll get a little bit more sample going up into the flame to give you even more signal. And then by adjusting your impact bead a little bit further away from the nebulizer, you'll get more signal. Your noise level will also go up a little, but the signal will also go up dramatically. So overall, the signal to noise performance will be much better. Now, what about if you're running more challenging samples, where perhaps there are higher levels of total dissolved solids? Again, here we need to make sure we have the mixing paddles in position, because that will enable us to get better mixing and to remove some of the larger droplets that can potentially cause blockage of the burner system. We want to adjust our impact bead. So from the optimum sensitivity position, adjust the bead about half to one turn clockwise towards the nebulizer from the optimum sensitivity position. That means you're going to trade off sensitivity a little, perhaps maybe see about a 10% reduction. But that does also mean you'll get less chance of blockage in the sample introduction system. And that means you'll get much better long-term performance and stability. It's also important to work with the wide bore capillary tubing when you're working with this type of application, again, just to reduce the chance of blockage. So those tips may just help you to be able to tune the atomization system to suit the application that you're running in your laboratory. We should also think about the procedures that we go through at the end of the day once your analysis is complete, because that also has a big impact on how the instrument performs and especially about how you look after the instrument. So I guess these are really the recommended shutdown procedures. So as we said earlier, it's important that we aspirate rinse solution for a few minutes before we shut off the flame, just to wash out the nebulizer and remove any remaining sample residue from the nebulizer. We can then extinguish the flame and allow the burner to cool. We should then remove the burner, and as we show here in the diagram, pour at least 500 ml of water through the top of the spray chamber. The goal here is to wash out any acid residue from the liquid trap. We can then empty the waste vessel, shut off the gases at the supply to the instrument, close the software and shut down the instrument. By following this procedure, it means we're going to flush out all of the sample introduction system and rinse out all that acid residue. And that means we're going to have less chance of blockage and less chance of degradation in the instrumentation. Here are some guidelines that can help you with cleaning the sample introduction system when it's required. The spray chamber and burner system is fairly straightforward from a cleaning perspective. So really what we want to do is disassemble all the different components, place them in a detergent solution, and then give them a good soak, and if necessary, use a cleaning brush to help remove any residue that's built up on those components. We can then rinse them, dry them, and reassemble those components. When we do that, we should make sure that we inspect the condition of the impact bead closely. If you see very bad pitting, as you see in this example in the photograph, then the bead should be replaced immediately, because it's not going to do a good job in terms of breaking up the flow of sample that's coming into the stream, into the sample introduction system. The other area where users struggle is when they need to clean the burner. We recommend polishing the burner, and particularly the inside of the burner slot, with a metal polish. We typically use Brasso, which is a liquid metal polish suitable for polishing brass. But if that's not available in your area, then another suitable polish like that should work equally well. We want to use the burner cleaning strips to enable us to introduce that metal polish inside the burner slot. And we use that card to actually polish the inside of the burner slot. We also polish the outside as well. The more you polish it, the better the performance that you'll get from the burner, and the better resistance that you'll have to blockage. So that's the most important aspect about cleaning and maintaining your sample introduction system. We should also think about the way that you're preparing standards to calibrate your instrumentation. And this is also critical because all of the sample measurements that are made are done with reference to the initial calibration. So the accuracy, the results that you get, are totally dependent on the accuracy that you have for your calibration standards. If there's any errors in the preparation of those standards, it's going to cause a whole host of problems for you. Obviously, inaccurate results is one possibility, but you may also then start to spend time troubleshooting, trying to identify where the problem is. That means you'll have instrument downtime. Potentially, you may even prepare new calibration standards and need to reanalyze those solutions. And that means you're going to be doing more samples, and so you'll get premature replacement of the critical instrument supplies. And there's even the potential that you may fail an audit and potentially lose your ISO accreditation. Increasingly, regulatory bodies, such as the National Association of Testing Authorities in Australia or the United Kingdom Accreditation Service, are requiring ISO Guide 34 certified laboratories to use certified reference materials where available to enable them to verify and validate their methods and verify and validate their results. So working with certified reference materials is really critical for your applications. This is where Agilent can really help you. Agilent provides a comprehensive range of certified reference materials that are ideally suited to preparation of calibration standards. They provide the highest level of accreditation, being manufactured in an ISO 9001 Guide 34 facility and certified in an ISO 17025 testing laboratory. Of course, they're high purity as well, made from the highest purity elements and compounds available, as well as using high purity acids and solvents. The raw materials are assayed and analysed for trace impurities using an Agilent ICP-MS. The samples or solutions are prepared gravimetrically in an ultra-clean environment. And of course, the containers that we use for packaging are also contamination-free, and they're designed to avoid contamination. The standards themselves, the certified reference materials, are certified using the high-performance spectroscopy protocol developed by the National Institute of Standards and Technology in the United States. And both the certified concentrations and the uncertainty values are directly traceable back to the NIST 3100 series of standard reference materials, which means that you can be sure they'll have the highest accuracy as well as, of course, of having traceability. Now, confirmation of the results is also important. So, of course, all the Agilent standards are supplied with a certificate of analysis that shows the actual concentration of the standard, as well as the potential impurities that are listed for up to 68 different elements. So you can be sure that the Agilent standards will give you the performance that you're looking for. And of course, they also provide a long shelf life, which means that you're able to, again, reduce the cost of your analyses in your laboratory. Agilent now offers a complete line of certified reference materials that are ideally suited to preparation of calibration standards for any of the atomic spectroscopy techniques. So they're suitable for atomic absorption, for microwave plasma, for ICP-OES, and even for ICP-MS applications. We offer a full range of both single and multi-element standards, including, of course, organometallic and biodiesel standards for customers that need to work with organic solvents or oil samples. In addition, we also offer some unique combinations with both environmental standards specifically targeted to environmental applications for both ICP-OES and ICP-MS, together with a range of matrix modifiers and buffers for atomic absorption. So you can see that with the Agilent certified reference materials, your laboratory can be assured of the range, but also of quality, purity, and consistency. So now let's think about some tips that we can provide to you to help you with standard preparation and to help you with some of the challenges that you may be facing when you're preparing calibration standards. We need to focus on the things that are fairly common, perhaps the things that we probably should already know, but maybe we don't always remember, or perhaps we're not always following these sorts of guidelines. So we have to think about how we're preparing our calibration standards. Of course, we need to make sure that our standards are within their use-by date. We want to make sure that we're working with the best calibrated pipettes and grade A glassware to make sure that we can achieve the best accuracy. Are you periodically checking the accuracy of your pipettes? We also want to make sure that we're working with pure water, deionized water, to ensure there's less chance of contamination. And of course, most importantly, we need to make sure that we work with serial dilution so that we can avoid introducing any large errors that are associated with doing a large dilution in one step. We also have to think about how we're storing the calibration standards that we've prepared. The standards should be acidified to make sure that they have the best stability. And of course, ideally, we really want to store them in plastic vessels because that will also help you provide better stability. The PFA of fluorinated vessels are the best of all, of course. We also have to think about the concentration levels that our standards have been prepared in. Particularly if you're working at trace levels, at ppb levels, or even at sub-ppb levels, it's critical that we prepare those low concentration standards fresh every time you run your instrument. That might be every day, it might be once a week, depending on your workload. But at those low ppb levels, the stability of standards can be poor. And that's why it's recommended that you prepare those trace level standards fresh every time you run your instrument. Now, if you're working in the ppm range, then it's still recommended that you replace those standards frequently, but usually there it's on a weekly or a monthly basis, again depending on the concentration that you're working at. You also have to think about the chance of contamination, because contamination can come from everything that your sample comes into contact with, whether it's during storage, whether it's during digestion, or even during analysis. So think about things like the purity of the reagents that you're working with. Always use the best reagents that you can and check the certificate of analysis for those reagents to look at the level of impurities that might be present, to see whether or not that will cause a problem with your particular analysis. It can vary from one batch to the next. So of course you want to focus on what is the level of potential contaminants in the sample. Checking the certificate of analysis will certainly enable you to highlight if there are any elements there that could potentially cause a problem for your application. The other potential cause of contamination is from the reagent water. So again, if you're not working with deionized water, if you're not maintaining your water system properly, then that can be a potential issue for you. Many users in the lab like to work with these coloured pipette tips, but that can also be a cause of potential contamination, particularly for elements like copper, iron, zinc, and cadmium. So generally it's preferred that you work with natural tips to reduce that chance of contamination. To improve the accuracy of your results, you also need to focus on your sample digestion procedures. You want to make sure that you're working with the most appropriate digestion method. So you may not be doing a hot plate digestion, as you see here in the image, but you still want to make sure that the method that you're working with is suitable for your application. And that's also just as important if you're working with a block digestion system, or even if you're working with a microwave digestion system. So you want to check to see whether all of the analytes are being quantitatively extracted and dissolved, or whether there's the chance that some volatile analytes are being lost during the digestion process. To do that, you want to take a solid certified reference material through your complete sample preparation and digestion process. If you see any loss of analyte or even some contamination, then you'll be able to see that from the results that you get for that particular material. Another check that you should use as a way of looking for potential contamination is to work with a reagent blank. And ideally, you should include that with every sample batch that you're measuring. That means you're going to take a reagent water sample through your preparation process and then measure that as a sample. Ideally, all the results should be close to zero. But if you observe higher levels, then that can highlight potential contamination coming through from your sample preparation process. So you may not need to do these types of checks every time you do your digestion process, but it's good to do this periodically, and especially if you're setting up a new method. Now let's think about one of the last checks that we should do if we want to improve the performance of our instrumentation. And that's really to check the analytical sensitivity that we're getting. So one of the things that most users often have trouble with is about burner alignment. We do need to optimize the burner position, both vertically, horizontally, and rotationally. And the best way to do that is to use the burner aligning and cleaning strips. You can position it on the burner and then use the target area as a way to ensure the burner is correctly aligned with respect to the light from the holocathode lamp. And that way you can do a very quick visual check to verify that the light beam is running parallel to the burner slot. It's also good practice to check the nebulizer uptake rate. Ideally, it should be in that range close to about 5 mils per minute. If necessary, you can adjust the nebulizer or potentially clean the nebulizer if there's a partial blockage and you have a low sample uptake rate. Once you've done those preliminary adjustments, you should then aspirate a standard. In this case, it's a 5 ppm copper standard, but you want to aspirate your standard and then optimize the system a little further for maximum sensitivity. And here we really want to focus on things like the impact bead position. So we can use the adjuster to make sure that we're getting the best sensitivity and best precision. Last of all, we'll focus on the flame chemistry, the flame stoichiometry. And this is especially critical for elements that use the nitrous oxide acetylene flame. But even for elements that work with an air acetylene flame, just by adjusting your gas flows, you can change the sensitivity that you're achieving and optimize your performance. As we said, optimization of the acetylene flow becomes even more critical if you're working with the nitrous oxide acetylene flame. These images here will give you an example of the optimization conditions that are recommended for the nitrous oxide acetylene burner. Usually when you're working with this burner type, it's because you need to measure more refractory elements. And these elements need extra acetylene to be added into the flame to be able to get good signal. So typically when you're running with elements that need a nitrous oxide flame, we add in extra acetylene. You'll see references in the cookbook to things like the feather or the height of the cone in the flame, and that's referring to the height of this coloured region in the flame that you can see here in the photograph. So we often need to increase that acetylene flow anywhere up to about 8 litres per minute to enable you to get the best sensitivity. And what you'll see is going from stoichiometric conditions to rich conditions, your signal will go up dramatically. So hopefully these images will help you the next time you need to work with the nitrous oxide flame.